Many science fiction stories suggest that if Earth becomes uninhabitable, we can simply board a ship and find a new home. But that optimistic fantasy ignores the sheer lethality of the deep cosmos. Most of what's out there is incompatible with life. Take 55 Cancri E, a planet composed entirely of solid carbon and diamond, subjected to temperatures exceeding 2,000 degrees Celsius. Even more surreal is Gliese 436. Despite burning 439 degrees, its surface is covered in a layer of ice that refuses to melt. Our own solar system is bookended by a similar brutality. Past Pluto, the temperature in the void drops to a staggering -270 degrees. The universe is a graveyard of extremes, where the physical laws of most planets would dismantle human biology in a matter of seconds. Survival requires a precise, impossible alignment of planetary conditions that we rarely see in the dark. For years, the search for a match yielded nothing. In 2015, a specific set of data points emerged that broke the streak of cosmic anomalies. This was Kepler 452b. Its size and composition were so familiar that researchers gave it a new classification, the super-Earth. Astrophysicists view this world as Earth's closest relative, a find that has redirected our understanding of where life might actually hide. A planet's potential for life is dictated primarily by its distance from its host star. When we chart the path of Kepler 452b, we find an orbit that is nearly identical to Earth's own journey around the Sun. The math is startlingly close. A single year on this planet takes 385 days, only 20 days longer than our own. Most worlds are either too close to their suns, resulting in a permanent burn, or too far, resulting in a permanent freeze. Because of its 385-day cycle, Kepler 452b occupies a thermal zone where the climate has the potential to mirror the moderate temperatures of Earth. This orbital positioning meets the foundational requirement for liquid water to exist on the surface, a rarity in a universe defined by extremes. Climate is only half of the equation. Unlike the gas giants that dominate so much of space, Kepler 452b is believed to be a solid, rocky world. Based on its mass and density, scientific models project a surface defined by massive rock formations and active volcanic cycles. These same projections suggest that the planet could indeed possess liquid oceans, churning against a massive rocky coastline. The combination of volcanic heat and surface water creates a geological engine very similar to the one that sustained early life on Earth. Kepler 452b appears to have replicated the physical infrastructure required to move a planet from a dead rock to a living world. Every metric aligns: a stable 385-day orbit, a moderate climate, and the presence of both rocks and water. This has led to a profound scientific hypothesis. Biological life could be surviving on that surface at this very moment. But this discovery is met with a reality that our current technology cannot overcome. Our twin is located 100,800 light-years away. We have found the perfect mirror to our own existence, yet it remains effectively isolated by the insurmountable scale of the galaxy. To understand the weight of that distance, we have to look at how much we've struggled to explore our own backyard. In 1970, the Soviet Union began the Kola Super Deep Borehole, a 20-year effort to simply dig into the Earth's crust. After 2 decades of work, they reached only 12.2 kilometers. They had to stop because the heat became so intense it began melting the machinery. That 12-kilometer scratch represents less than 1% of the way to our own planet's center. It is an insignificant distance compared to the 100,800 light-year void between us and our twin. While we remain anchored to this world, Kepler 452b proves that Earth is not a cosmic accident. It suggests that out in the darkness, the recipe for our existence has been written more than once.